Now we will calculate our P-chart. The textbook provides us with an example. It has samples from the work of 20 clerks. I have put that information here. I have some formulas over here that we need to solve for. In the text, we are given 20 samples. There are 100 items inspected from each of the samples, and then here are the defects that are found. You can do this one of two ways. You can put n of 100 up here, and then just when we're calculating the percent defect, you can take this over this and make this absolute and then just copy it down. But a lot of students like to see the number inspected corresponding to each sample, even though it's the same. So you can put them in this way. I've put them in both ways. I'm going to just go ahead and calculate them, though, using relative references, 6 over 100, 5 over 100, 0 over 100, to get the percent defect. So I'll do that here, 6 over 100. And I'll copy that down. Double click on the autofill node and it just copies that equation down. I'll click down here, press F2 to check my work to make sure that it has been done correctly, and yes, it has. All right. Now, that is calculating P sub I, or the probability of percent defective. Here was the formula that we used. In order to continue, though, we need to know the total defects. We need to complete this section. The total defects is just the sum of the defects. So let's get this, the sum of our defects. There we go. We had 80 defects in total. So I'm going to place that value up here. I'll just point to it, 80. Next, we have to determine our sample size, and the sample size here for each one, n. We've already identified that, and that's here. We'll just point to that. And the number of samples is 20. You can type in 20, you can take the maximum value of that column. However you want to do it. I'm just going to put in 20. Now we need to go ahead and calculate P bar. P bar is simply the total defects, which we have, over the quantity sample size times number of samples. So let's calculate that. We'll take the total defects here, and we'll place that over the quantity sample size times the number of samples. Gives us 0.04. Now we need to come up with sigma sub p. You can see that this formula here, we'll go ahead and do that. That's a square root, so we'll place this square root. We'll go ahead and get the quantity P bar times the quantity 1 minus P bar. There we go. That's our numerator over n, which we calculated up here. And we have calculated this value as 0.0196. In the problem example, the supervisor wants to have a margin of error, a confidence interval of 99.73% or 0.9973. This is a two-tailed test, so we're going to go ahead and calculate that to be a z of 3. I'll go over this in class. It's another calculation. It's not difficult. But the z value here is 3, and we need z. You can see for these calculation, so you might want to just plug a 3 in there. In the exercises, you will be given the value of z. Now we need to go ahead and calculate our upper and lower control limits. And the lower control limit is here, p bar minus z times sigma sub p. Now this creates a problem. We can't have a lower control limit less than 0. So we need to make a change to this formula. We're going to use the max function to look at 0 and our value that we calculate. So I'll put a parenthesis right there. What this will do is if our value comes back less than 0, it will substitute 0 because 0 would be larger than the negative number. If our value comes back positive, we'll get our value. So we'll go ahead and do that. And you can see now it's 0 as opposed to a negative number. Now we'll do our upper control limit, which is p plus z times sigma sub p. And there we go. Now we're ready to draw our control chart. We'll put our values over here for our chart. We need the upper control limit, so we'll get that. There it is. We'll make that absolute by pressing F4. We'll get the lower control limit. There it is. We've calculated it here. We'll make that absolute by pressing F4. We'll get the control limit, okay, or P bar right there. Press enter. Go ahead and select those. I'm going to just double click on my autofill node. That should fill those all the way down. Now, again, if I select these values, it will make plotting this a little bit quicker. I'm going to go ahead then and insert a line chart, and I want the line with markers charts. The other ones won't work. Say OK. Move this out of the way so you can see. Change my chart title so you know to a PChart. Now I've selected my chart here, and I'll go up to my Design tab, my Chart Tools, and select Data. I have to put in the actual p-values. So I'm going to add, and then I'll go ahead and put in the series name. And select. These probably could have gotten away with selecting all 4 of these columns. Just in the habit of not doing that because it doesn't always work with the control charts. But in this case, it would have worked. And I will say, okay, I can change these if I want to 1 through 20, but they're already going to be 1 through 20 because they're numbered sequentially by XL. And here's my PChart. You can see I have a couple of issues here. This is a problem. And these two are probably issues as well that we should look into. This wouldn't hurt to find out what happened here as well. That completes the PChart calculation exercise.